All right, let me show you the test without showing the camera, because then you can just zoom in and get all the questions. Here's the test. No big surprise. Turn that front line on for a second. All right, I've got the first four. They're going to be metric conversions like these. Got to show me the work, like I showed it to you. The next six are going to be scientific notation like those, and then some multiplication and division in scientific notation, which I didn't put in here, but you have to do too. The bottom four are going to be density problems like these. There's only two up here. This is representative of the test, but obviously not as long as it, because I want to go over it. On the back, you got a deviation chart, average deviation, which we've done in the popcorn lab, the density lab, in notes, okay, multiple times. You'll have some questions and other problems on percent error, accuracy versus precision. And then the only questions you really have that are multiple choice or matching or that kind of thing is going to be on, these concepts right here. You can turn the light off again because that's basically the last thing on the test. These concepts right here, you're going to have at the very end, either in a multiple choice matching kind of format, classify the following as fundamental versus derived, heat versus temperature, quantity versus unit, and there is a short answer question on one of these concepts as well: accuracy, precision, heat, temperature, mass, weight, those kind of things. There's going to be a short answer question on that. Now, that's the minority of the test. Obviously, about 80-some% of the test is problems. The other 15 to 20% going to be questions on these concepts down here. Okay. All right. Let's go over this. See if you got them all right. And this is the kind of test. It's the exact opposite. You rarely hear a teacher say this, but this is one of those tests you don't have to study for. You really don't. With the exception of those couple of things in the bottom over here. You're either going to, by now, I hope, know how to do metric conversions and all that other stuff, or you don't. And if you don't by now, the only way to help yourself is not to study, but to do more of those problems and to correct the ones you got wrong on the worksheets and the homework you've already done. You don't go home and read through the chapter to do well on this test. No one should. No one should go home and study for this test in that way, shape, or form. You should basically be able to do these conversions from having done so many of them before. It's a process. It's not a memorization. So let's do the first one. All right, for 1 and 2 here. We'll do those. Okay. 85.4 grams. I want to convert them to centigrams. Oh, boy, that's thick. I don't want that. Let's go with this and then this. All right. What do I do first? I write down the given information, 85.4 grams. And this is the review day, so I go pretty fast. We only have about 15, 20 minutes to go over all these. All right, now I want to do them quickly. You should all know this by now. Like you should know what goes in the bottom. Grams, why? Because they cancel. That's not memorization. That's common sense. If I put grams on the top, I'm going to get grams squared. What goes on the top? Centigrams. Why? Because it asks me for centigrams. If I don't put them on the top, I'm never going to get the answer. Then comes the only thinking part to this problem. How many centigrams are in a gram, or vice versa? And here's where you ask yourself a question. Who's bigger, a centigram or a gram? A gram. So he gets a 1. I can fit 100 centigrams into 1 gram. Now, these are the 6 things you need to know. Kilo, hecta, deca, deci, centi, and milli. That's it. That's all you need to know. Those. You should know by now that means 1,000, 100, 10, 100, and 1,000. Okay? That's what you should know. That's what you're going to be putting in there. There's 3 numbers you're going to put in for 6 guys, 100, 1,000, 100, or 10, and a 1 somewhere else, pretty much in every case. Now, once you've done that one thinking step, everything else is a piece of cake because it tells you how many places to move it. I'm going to move it 2 zeros, 2 places, and it tells me which way they're going to move it. Which way am I going to move this guy? Am I going to be bigger or smaller? Well, he's in the top. I've multiplied. Rabbits multiply. You get more of them. 8, 5, 4, 0, right? 2 spaces to the right. You all get that? I hope. Good. All right. And by the way, you get partial credit on these, whereas if you don't show me this work, you're not going to get partial credit. Let's do another one. Milliliters, deciliters, I purposely picked one that will take a double conversion. 257 milliliters. I got to convert to deciliters. Most of us don't know how many milliliters and deciliters. Your old system, I'm going to guess how many spaces to move it in which way. This way, you don't have to guess. It's common sense. I know milliliters go on the bottom. I don't know how many deciliters. I have no idea, so I go to liters. I do know there are 1,000 milliliters in 1 liter. 1 liter is bigger than a milliliter, right? I know that. And then I can do the second one. Now, I know this is more work. I know you hate doing more work. But you'll get it right more often, and you'll understand it better if you do it this way. Liters at the bottom, decaliters on the top. Now, here's where the reason why I said in the beginning, you won't get any more right this way. Because those of you who still didn't bother to memorize kilo, hecta, deca, deci, centi, and milli, you have those six things to memorize. You can't do this right. You're guessing now. I don't know, deca, is it bigger? So I forget which one. Is it 10, 20, 100? I don't know. One deca contains 10 liters. The A is the bigger one. D is the smaller one. And if you have that backwards, I'm not surprised. All right, now I know how many places to move it. 1, 2, 3, 4 zeros. All of them making him what? Smaller. So 1, 2, 3, 4, 0.0257 decaliters. Got it? Good. All right. Let's do the next one. Convert the following to scientific notation. Let's do these. 45000. Again, first mistake I'll see here. As a 45 times 10 to the third. Okay, they'll just do that. 1, 2, 3. Okay? Wrong. Got to move one digit only to the left of the number, so it's going to have to be 4.5. Another mistake. 4.5000. Is that correct now? What's wrong with that? Too many significant figures. Just added significant figures. The whole point of using scientific notation is we don't have to write all those zeros out. So 4.5 times 10 to the fourth. I hope you all got right, right? Good. All right, this one here. 1, 2 spaces, 5.67. Move them over 2 spaces. Now, because I made him bigger when I did that, I better multiply by an exponent that's going to make him smaller. So it is a 2 up here, but it's a what? -2, exactly. And that's because he's a fraction, and we'll make that guy smaller, back by 2 spaces, so they're both equal. That's the key. So that guy, like I taught it to you a while ago. And finally, this guy right here, you say, here's the mistake for this one. Well, 0.0035. Oh, okay, that's what they'll put. I bet somebody put that right now. What's wrong with that? Well, I asked you to put it into scientific notation. That's standard notation. And there's another mistake with it. I added an extra significant figure by keeping that 0 there. No, the correct answer for this guy is this. I got to move him over 2 spaces and make him 3.4. And then, since I made him, this is the tough one now, I made him smaller by 2 spaces. I got to make him bigger by 2 spaces. How do I make a -5 bigger by 2 spaces? -3. I bet a lot of people have -7. Okay? Okay? Got it? All right, good. Next one. So, the first 4 questions are on this. Next, like 6 are on scientific notation. Of course, converting into standard notation, there's some of them too. How would I do this guy? Pretty simple. I'm taking 4.83. I'm multiplying him by a negative exponent. I'm going to make him smaller by 4 spaces. Did you all get that? Okay. And this guy here, I'm making him bigger by 5 spaces. You all get that? Look good? Okay. Any problems? Stop me. If you don't know. So far, I think we're doing stuff that I've gone over so many times, I can't imagine there's a whole lot of problems. But as we do these other ones, let me know. All right, solve for the missing variable, and I will do something like this in some of the word problem. Density, mass, volume. I know I'm looking for D, so pretty simple. I write this down every time. I need to see this. This is what I mean by work. Those of you who have been getting your labs back, your worksheets back, and even the homework today back, I wrote down on a couple of people, work. No work. Didn't show the work. You got to show me the work like this. And even for the metric conversions, you got to show me the work, like I showed you. Grams on the bottom, milligrams on top, whatever. Unknown, the mass is 18.5 grams. The volume is 4.789 milliliters. D equals M over V, 18.5 grams over 4.789 milliliters. I got to keep my significant figures, and I got to divide those out. What do I get when I divide? Sydney, what do you get for that answer?
3.87 grams per milliliter.
Anybody else get that?
Yeah, 3.86.
3.86. I would not mark either one wrong. My guess is it was somewhere close to that, 3.86 something. She rounded up, you rounded down. There probably was a correct answer. I don't know what the calculator said, but if it was above 5, you should have rounded up, and if it was below, you should have rounded down. But that's not what I'm going to take off for. I would take off for having the wrong number of significant figures, like 3.876597 or 3.870. I take off for that. And, of course, I take off for any of the other real mistakes. Okay? So rounding up or down, I don't know who was right. It doesn't really matter. Okay. Next one. This guy, I'm asked for the mass, And I'm not going to rewrite them over here, just to save myself some time. We only have about 9 minutes left here. So D equals M over V. I have to rearrange this guy. Now the algebra, in your class, this class, I mean, it's a different world teaching you guys versus teaching the rest of the school. All right, I would spend days practicing the algebra for this for a lot of other people. You guys don't need it. You all had algebra, probably almost all of you had algebra in 8th grade. And the other ones who didn't did well in it anyway, I'm sure. The rules of algebra are very simple for an equation like this. I'm looking for mass. I've got to get mass by himself in the numerator. He's already in the numerator. I'll multiply both sides by V. So V times D equals M, right? And that's what you should have done. Then you simply plug these two guys in, but we have a problem. And that's the reason why we write stuff down. I guess I should have done the writing down on this one, not on the other one. I've got 2.45 grams per milliliter, but I've got deciliters over here. I can't use 38 deciliters, and I bet some of you did. Okay? Because that's not the same unit. How do I convert 38 deciliters to milliliters? Deciliters on the bottom, liters on the top. 1 liter contains 10 deciliters. Then, liters on the bottom, milliliters on the top. 1 liter contains 1,000 milliliters. Right? You could cancel that 0 with that 0. I've got 2 spaces. I'm making them bigger by 3,800 milliliters is what you should have used as your volume. I'll bet a lot of people forgot to do that. So, M equals V times D, so it equals 3,800 milliliters times the density, which is 2.45 grams per milliliter. Milliliters cancel, leaves you with grams. Don't forget to keep your units, too, like you had to do in all the other stuff. Multiply 2.45. What'd you get for that, Gabby? 9300. I don't know. Looks good to me. It's the right number of significant figures anyway. Everybody else get that? Everybody else get that? Good? All right. Now, that's the density problem. They're at the bottom of that front side. We're done with the front side now. Back of the test. What's on there? Well, there will be a percent error question on the back of the test. You know how many times I saw every lab we did, and we did a lab, we did what, 2 or 3 times in the lab, we had this chapter. We had to do a percent error. The most recent one being yesterday for the popcorn lab. All right, hopefully when you looked it up last night. I hope eventually you get to the point where you know that, where you know percent error formula. Because you're going to use it in labs pretty much throughout the year. And it's just going to be EA over the accepted times 100. All right, the EA is not the 20 meters. That's not the observed value. What's the EA? The accepted minus the observed. So it would be 25 minus 25.0 meters minus 20.0 meters. Doesn't matter which way I do that. You say, well, you did accepted minus observed, accepted. Doesn't matter, because what do I have to do with that number? Absolute value. So whether I took 20 minus 25 or 25 minus 20 makes no difference. It's just the difference between them. The accepted value it tells you is 25, okay, 0.0 meters. And when you do that times 100, what do you get for that answer? 20%? Anybody else get that? Okay, 20%? Good. Now, that's percent error. There'll be a question on that guaranteed on the test. Also a question about it, not just a problem. You should know the difference. What was my little demo I did for accuracy versus precision? Remember that? Remember the Nerf gun and the target? Can you explain accuracy versus precision with something like that? Hopefully you can, because that's the difference between them. If you don't remember that, look it back up. The definitions of accuracy and precision are important as well. Accuracy was how close you were to the bullseye. Precision was how often we could repeat that over and over again. All right, next one. Oops. How many significant figures are in the following numbers? Now, look, we've been doing significant figures even for all of these, but very quickly. How many are in that guy? 4. No. 3. 1, 2. I'm converting here. These guys don't count. Everything after does. Those 3 are significant. How about here? 2. When there's no decimal, you start that arrow from the opposite side. Those 2 are significant. If he has a decimal, you start it from the left side. And, of course, I immediately hit a number, so everything after is significant. 3 in this case, right? Okay. We've been doing that all chapter long, too. And this is the key to all this. these don't go away. All right, none of this stuff you're doing here is going to go away like it does in your other classes. I know that's one of the reasons why you had forgotten and done wrong a lot of these scientific notation problems. You learned it. You learned metric conversions, yet you were getting them wrong earlier on, and now hopefully you won't because you're going to use them all year long. All right, so what should I do for the rest of the tonight if I was going to go home tonight? My guess is you got most of these right. You don't need to study them. I would do this. Make sure you know what kilo, hecta, deca, deci, centi, and milli. It's not going to be on the board. It's been on that board over there all chapter long. I didn't care if you used it for any worksheet or homework. It's not going to be there for the test tomorrow. You need to know them. I would make sure you go home and study these few concepts. That's it. You don't read through the book. You don't have to read over your notes. Those few concepts are where your questions are going to come from. Can you tell the difference between a quantity and a unit? What does it even mean to be a quantity versus a unit? Can you tell the difference between heat and temperature, fundamental versus derived physical properties? Okay, all that stuff here in accuracy versus precision and mass and weight. Those things are on multiple choice matching kind of format and one short answer question. The tests are not the same. Different people will have different tests. All right, and so they'll have different questions about this as well. All right, that's it. Any other problems? Any other questions? Okay.